Hey, hello everyone. Welcome to the A Math revision session for the mid-years. So my name is Kaiwan, and today I'll be doing a revision session for all the mid-year topics for the Sec 3s and Sec 4 students. So first up, let me introduce myself first. So my name is Kaiwan. I'm the A Math tutor and E Math tutor for Overmark. I've been teaching for about 5 years, and currently right now for Overmark, I teach the crash course and I teach the group tuitions. So I do have group tuition classes happening for both A Math and E Math. And yeah, currently I have like 4 to 5 classes, and if anyone is interested, you can actually join in to my classes, and then yeah, you can learn from me. So some background about myself. This is me, and this is my picture. So I'm currently studying in NTU at the moment. I'm in my 3rd year. And fun fact, I just completed my last final paper today. So I have a 3-month holiday now, starting from today, of course. So I'm moving on to my 4th year next year, and I'm studying mathematics in NTU. So studying mathematics, I study the branch of pure mathematics. So if anyone is interested, you can go and read up on what is that. But my areas of interest is under the geometry side, both in differential and algebraic sides, and also topology as well. Okay, so what am I going to do today? So someone I think asked just now. So first thing is that I'm going to do an overview of the upcoming topics for Sec 3 and Sec 4s. So some of you might be wondering, like, why is my session a bit different from the other subjects? Is because I don't have too much time at the moment. So I have no choice. I combine the 2 sessions together, but I realized that it's actually a very good thing that I combine them together, because most of my Sec 4s or some of my Sec 4s I've actually forgotten some of your older topics, and that is pretty sad. So that's why I think having a session together will be good, so that you revise your Sec 3 topics and Sec 4 topics as well. Then for my Sec 3s, they are in the call. Once we hit to the differentiation portion, then it will not really be applicable to you anymore. So for those, you can still stay behind and just have a listen to what is upcoming for the syllabus and what your other students are, what your other what you call it, cohort is actually going through at the moment, and what you'll be covering next year. Okay. I'll be giving you a list of topics to look out for, and if possible, I will dive into a little bit of detail for these topics later. And also, I'll be doing a full syllabus revision. So later, I will tell you which topics I'll be taking out, because either the schools haven't covered yet, or because I don't think it's necessary for today. Okay. Also for my Sec 3s, right, if possible, you stay until the very end. There's a Kahoot session at the back. So after this Kahoot session, then you can win a copy of the curated notes for free. So if possible, stay behind. Then yeah, you can actually participate in this activity. Okay, so this is the syllabus for A-Math. So personally, I feel that A-Math is actually easier than E-Math. I think A-Math is actually a very easy subject compared to the rest in the whole like Sec 4 curriculum, because I mean, to me personally, A-Math is a very brain dead subject, because you don't really need to think too much. It's just do. Okay, so the topics that I'm going to be leaving out today will be proofs in plain geom, because the Sec 4s haven't covered it yet in school. I'll be taking out kinematics and also integration. So I will stop purely at differentiation, and the differentiation I will most likely go through the whole topic, but I think most schools have only just nice started integration, so I will not do integration for this revision session. So I have a total of 7, 8, 9, 10, 11, 12 topics to complete in about an hour and 15 minutes. I should have enough time, should be. Okay, so let's see, of course. Okay, so topics. So Sec 3s and Sec 4s respectively. Sec 3 topics that are difficult. I think some Sec 3s are now, or most Sec 3s will be touching your exponential and logarithms, or completing the exponential and logarithms chapter, moving on into linear law, or moving on into further coordinate geom, which is the circles. Most of the time, these 3 topics of trigo, coordinate geom, and exponentials and logarithms will kill a lot of students, because a lot of people are very weak at them. So please go and practice, find as many resources as possible to go and look for them. For the Sec 4s, okay, basically your whole calculus is actually not easy. Of course, for me personally, I don't think it's very difficult. You just need to practice a lot, okay, but it will be doable. Proofs in plain geom is a topic that I think most schools have not touched at all. The reason is because this topic is a disgusting topic. It's a very difficult topic. Why? Because it combines all of your difficult topics from eMath into one topic. Okay, so I will not touch on this. If you're interested, you can go and read out first, but yeah, I'm not going to go into this. So without further ado, for those that are here with me today, I'm going to start and hope you enjoy the session. So get some food, get some popcorn, and enjoy me talking for the next 1 hour and 15 minutes. So the way that I'll be lecturing through this whole syllabus is I'll be using my notes. Now these notes on this black piece of paper, I will upload, I repeat again, I will upload into the Telegram channel at the end of the day. So after this session at 8:30, I will upload the eMath one and the AMath one. Okay, so if you don't have time to copy, which I highly doubt anyone will have, okay, you can actually refer them to them. I wrote these notes last year, so these notes are a little bit old. I'm currently in the process of writing the new version. Once those are ready, then I will upload into the channel as well. Okay. I will be referencing to my curated notes as well. So once in a while, I'll pop into my curated notes there so that you guys can actually see what my notes look like, and also some of the content that I left out on purpose from this set of notes. Okay, if anyone has any questions, right, you can just ask straight away into the chat. Do not need to direct message me. But of course, if you're too shy, then go ahead. But please, if possible, just send to everyone, because there are some people there that can answer. So if you can answer the questions, feel free to just answer. Okay, no restrictions or what. But please, of course, if you're answering, please give correct answers. Don't give wrong answers. Okay, if you give wrong answers, I'll come after you. So please, if you're helping, please help properly. Okay, and the last thing is that, like I mentioned just now, I don't have the time for a Q&A session at the back because I do need to rush off at 8:30. So for the purpose of that, I'll give you guys my Telegram. I mean, most people know my Telegram already. You can just PM me your questions and I'll help you latest by tomorrow or Friday. Okay. Okay, without further ado, let's begin with the first topic on quadratic functions. So for quadratic functions, the first thing that we need to remember is about completing the square. So I assume that if you're taking AMath, your completing the square should be pretty strong, or should be at least passable. So you need to remember that for completing the square, we're converting an equation, y is equals to ax squared plus bx plus c, into the form y is equals to ax minus h whole squared plus k. That is the main form that we're going after. And the turning point is h comma k. So I've shown you an example here of how we're going to complete the square. Unfortunately, I don't have the time to go into detail as to how to complete the square properly. If you have problems with this, either ask in the chat now, or you can actually just PM me and I'll help you. Two things about this completing the square method. Number one, you need to make sure that the coefficient is always 1. So if let's say there's a number in front, you need to factorize it out in order to get it right. Okay, or else you will complete it wrongly. Same thing for the coefficient, it must be positive. If let's say there's a minus sign in front, which is most of the time what question sets, you need to remember to pull them out so that you don't make any mistakes. Now this concept here, the next concept is about graphs that are always positive or always negative. So you need to remember that if your graph is always positive, okay, this is how I remember my thought process. If the graph is always positive, there is no intersection between the graph and the x-axis, and therefore there are no solutions. This is very important because a lot of people see that the equation is positive, right? Oh, straight away b squared minus 4ac greater than 0. No, that's not true. You need to remember that if you have a curve floating entirely above the x-axis, okay, I hope you can see my video. I never off my video. Oh shoot. Sorry. Yeah. Okay, sorry. On my video. So the axis is here. The graph is here. Okay. So the graph will be floating above the x-axis. There is no intersection between them, hence no solution. This is how we remember them. Okay. Conditions for the graph to always be positive and negative. You must remember that two conditions. Number one, the b squared minus 4ac is less than 0. And number two, you always need to check that the coefficient of x squared must either be positive or negative. This is a common thing that many students will forget to check, so please remember to check. Chapter 2, Equations and Inequalities. So this chapter is different from the first chapter. The first chapter is mainly focusing on graph sketching for the completed square form and the positivity and negativity of a quadratic function. For equations and inequalities, we are diving down into discriminants and talking about the quadratic side and the line and the curve side. Afterwards, we will talk about inequalities as well. So let's talk about the discriminants first. Now, the discriminant comes from the b squared minus 4ac. In case you guys didn't know, it comes from the quadratic formula. From my quadratic formula, it is negative b plus minus square root of b squared minus 4ac over 2a. If you observe the square roots, this is the main deciding factor as to whether there are two answers, one answer, or no answers. I've broken it down into two main concepts, quadratic equations and line and curve. So let's talk about the quadratics first. Now, if your quadratic equation has two real and distinct roots, it means that the discriminant value is greater than 0. This means that you are able to get both the positive square root answer and the negative square root answer. And that's why there are two solutions. For the real and equal, there's only one solution. This is because whatever is within the square root will become 0. So you're just left with negative b over 2a. And that's why there's only one solution. So the word equal is very important. So remember that. Number 3, no real roots. This means that your discriminant value, b squared minus 4ac, is going to be less than 0. Okay, you're square rooting a negative value, which is wrong. Okay, it's not possible to actually square root a negative value for the O-level syllabus. So hence, there is no real solutions. And for the very last one, okay, this is an extra condition. So for the real solutions, right, if the question just say, show me that the solutions of these equations are real, this means that we need to consider both number 1 and number 2. So note that number 1 and number 2 both have the word real there. That's why we need to classify both of them. That's why it is greater than 0 and equal to 0 at the same time. Okay, excuse me. Next, we go into line and curve. This is exactly the same thing, so I don't want to repeat myself. But just remember that if there are two intersection points, this is when your discriminant is greater than 0. One intersection point or tangential, this means that the discriminant is equals to 0 because there's only one solution. No intersection point means there is no solution. And when you intersect only, okay, it means it can either have two solutions or one solution. Okay, not a difficult concept. These kind of questions are giveaway, so if possible, try to score them as much as possible. Last one is for the quadratic inequalities. Okay, whenever you're dealing with quadratic inequalities, there are two cases here. So the cases are when it's greater than 0 or less than 0. Now, when it's greater than 0, you just need to remember it is floating, or you're looking for the points that are above the x-axis. Points that are less than 0, right? It will be below the x-axis. So it's drawn in this way. Now, what is this trick here? So basically what I tell my students is to imagine that they are standing here. Oh, sorry. So I'll draw myself standing here. Okay. And then I'll ask myself, okay, if my arrow, okay, I'll treat this as arrow signs. If the arrow is pointing towards the right, then it will be outside. If it's pointing towards the left, it is inside. So it depends on how you want to memorize. It's up to you. Now, take note, this particular graph that I just drawn here only works for coefficients that must be positive. Okay, the coefficients of x square must be positive. If your x square is negative, try to always factorize them out, flip the inequality sign. Unless your school teaches you how to sketch the negative curve, then go ahead. Personally, I feel that learning both negative and positive is very confusing. So just be careful. Do whatever works for you. Personally, I will just factorize out the minus sign and just memorize this method here. Okay, take note that these positive curves and the negative curves are different. So do not confuse yourself between the two. Last one, there's a very special class of questions here, okay, which we call the show questions. So for show questions, right, whenever we want to prove that something is greater than 0, prove that there are two intersection points, prove there are two real and distinct roots, we must remember that you cannot assume the discriminant value. So many students make this mistake, and it's very sad. Okay, please do not do that. When the question asks you to show, it means that you need to reach that result. It doesn't mean you take the result and just go. No, doesn't work that way. Okay. So the way that we do it, right, is to find the discriminant value first, get the quadratic out, and then you complete the square. Because by completing the square, you can actually tell whether the value is it going to be positive or negative. Now, scatter around the notes, if you see like page numbers or like these kind of things, right, they are actually just references to my curated notes. So I'm not going to go there at the moment, okay, but yeah, just take note that this is the very, very important class of questions that a lot of students cannot do. Okay. Certs. Okay, so I'll do certs first, then I'll look at the chat for some questions. Sound like a live streaming, but yeah, I'll look at the chat for some questions. Okay, for certs. So certs, right, is just basically one concept on rationalization. So rationalization is the process of multiplying the denominator by a conjugate, and we call this a conjugation. So a conjugate, in case you forgot, is basically just flipping the middle sign. So if it's A minus B, the conjugate is A plus B. And the reason that we multiply by the conjugation is so that we can actually get rid of the certs in the denominator. Why is that the case? Because you must remember that your certs in the denominator, when you're multiplying by the conjugate, you're going to do A plus B, A minus B. And that will actually be A square minus B square. It will actually get rid of your square root. Okay. So that's why this is a very important trick that I teach my students, this one here. Just remember that your denominator is very unique. You can actually use the calculator to get out the denominator answer because it's guaranteed to be positive. It's guaranteed to be integer. Okay. Numerator cannot, because the numerator will have a square root, but the denominator is guaranteed to have a no square roots at all. Now, some specific question types that we want to look at. First one will be this one here. So whenever you have a compound number within the cert, so a compound number is a number that is not broken down into prime factors yet. What we do is to break them down first into prime factors, use cert laws to split them up. Okay, so example, there's an 80 here. 80 is the same thing as 2 power 4 times 5. We split up, we will actually get 4 root 5. Next one here, for this kind, how do you simplify root 2 times root 6? The way to do it is the same thing. There's a 6 there, it's a compound number. So you split them up into root 2 times root 3. The 2 root 2's down there will actually multiply together and you'll get single 2. Now, in case you're wondering why root 2 times root 2 gives you 2 in this law. So 2 to the power of half times 2 to the power of half is 2 to the power of half plus half, which is 2 power 1, which is 2. And the last one down here is how do you pull out numbers that are inside the square root out? Basically, you just need to split the certs up and then divide the powers by 2. Only when you can do it this way, then you can get rid of your certs. Okay, so same thing as multiplying in. So for example, 2 root 5, I want to multiply the 2 in. I just need to square the value so that I can push it in. Okay, great. Polynomials. Now I'll take a short 1 minute here. Let's read some questions. Okay. How does the graph model equal to okay? I believe the graph is the same, but the answer. Okay, nothing. So polynomials. So for the polynomial chapter, we're going to talk about long division. So long division is basically this statement here. F of x is equal to gx, qx plus rx. We call this the division algorithm. So in this division algorithm here, okay, there are different things. The fx is your function, the gx is your divisor, the qx is your quotient, and the rx is your remainder. Now it is important to know what the names are and the locations of them during your long division process. It's the same thing as when you're doing your primary school long division. 3 divided by 2, you put the 3 inside the long division symbol and the 2 is on the outside. It's the same thing as you did in primary school. So if any of you exams get it wrong, please go back to primary school. Okay. Now, let's talk about the remainder theorem. So remainder theorem means what? Now, remainder theorem means that there is going to be a remainder. So it will be written like this. I'll write out the division algorithm. So f of x is equals to gx qx plus rx. Now, I want to get rid of my quotient because quotient is something that is very difficult to find. Or in this case, something that you do not know or you do not want to know. So what I'm going to do is to get rid of the quotient by forcing the gx to be 0. And how? Choose a value of x such that you can get rid of the gx. So for example, in this case here, if it's x minus 2, when we substitute x as 2, the whole function there will go to 0, the quotient will vanish, and you'll get rx. Now, it's the same thing as the factor theorem. So this is the next page. So for factors, what does it mean by a factor? So from eMath, factor means that you're able to divide something exactly with no remainder. So that's why in this division algorithm here, there is no remainder. Same process, we'll just identify what is the value of x to substitute in so that we can get rid of the quotient. So in this case, excuse me, it will be f of half equals to 0. Okay. Next concept here will be cubic equations. So for cubic equations, now there is a step-by-step process that I usually teach students how to do, and I'm going to share them with you guys. So step 1 is to first thing type into the calculator. In O levels, all your cubic equations won't have funny answers. Most of the time will be 2 cases, 1 beautiful answer, 2 disgusting answer. So you listen to how I say 1 beautiful, 2 disgusting, or 3 beautiful answers. It can be any case. So I'm going to split up the 2 cases. First case, I'm going to talk about the 3 beautiful answers. When I mean an answer is beautiful, I mean integer or rational number. If you forget rational numbers, it means fractions. So anything that gives you a whole number or anything that gives you a fraction are things that are very nice. They are very easy to solve. And what's the method that I use? I use this method called the smart trial and error. So I'm going to go into my curated notes and show you. So page 63. Oops, not 63, 64. So the smart trial and error method, right, is basically just writing this template here. For example, if the value is x minus 1, and this is the factor from your calculator, what I'm going to do is this. I'm just going to say, I'm going to let x equals to 1, show the substitution, show that it is equals to 0, therefore it is a factor. Ta-da, finish. Okay, whenever you are dealing with beautiful answers, we write it like this. So we don't need to go through the long process of literally guessing number by number by number. It's a waste of time. Okay, so use the calculator. If you don't know the button combination, mode 3, 4. Okay, it will give you your cubic equations. Oops, sorry. Now, let's talk about the 1 beautiful and 2 disgusting. So disgusting numbers are like decimal or complex numbers. Okay, complex numbers not in your syllabus, but it's those that have the letter I. Okay, those that have like the 3/2 plus something I. Those are complex numbers. Those are only in A levels. But if you see those, or you see like those decimals that go non-stop those are what I call disgusting, because there's no fixed answer for them, or there's no nice answer for them. For this kind of disgusting answers, for the decimal ones, we solve using the quadratic formula. So this means that you need to find the quadratic factor. It's a must. And then for the complex number one, usually is for questions that will ask you for the number of solutions. Those kind of questions, you'll tie back into discriminant. You just need to show that the quadratic factor has no real roots, therefore no solution. Okay. So for case number 1, the method that I will usually do is long division first for the first step, and then you use the quadratic formula to actually get out the 2 disgusting answers. If you see that your answers are complex, then you just find the quadratic factor, then do discriminant on your quadratic factor, show that the discriminant is less than 0, therefore no real roots. Okay. Cubic identities. Now this is important. So cubic identities, remember the formula, not given in exams. It is always, you must memorize. Okay, and a lot of people will gundu here. So please be careful. A cube plus B cube is the same thing as A plus B, A square minus AB plus B square. Remember that the numbers are opposite, the signs are opposite, and there's no 2. Okay, please don't be a gundu and write a plus b, a squared minus 2ab plus b squared, because that is a common mistake. And then you will get a plus b, a squared, a plus a minus b squared, and that is wrong. So please be careful, write them properly in exams. Now let's move on. Simultaneous equations. Now this is a chapter on its own, but I'm not going to cover because the concepts are too easy. Just remember that whenever you're doing any like funky substitution or what, make sure that you're substituting the linear factor into the non-linear. Please don't be a strange person and do the reverse. Okay, you do the reverse, you do until tomorrow also cannot solve. So please be careful. Another thing, please always, if possible, avoid fractions, because whenever we are dealing with like substitution of fractions, a lot of students will make mistake. So if possible, we always substitute linear terms, things that are very nice, very easy to solve. Okay. Partial fractions. So yeah, I will do partial fractions first, and then I will look at the chat. Okay, I should look at the chat first. Okay, questions. Oh, I love AMF. Yes, same. I love AMF too. AMF is easy. You can get full marks on. This is only used when the equation has a power of cube. Sorry, Valerie, no clue what you're talking about. What is the discriminant used for? Discriminant is basically not to find solution. That's wrong. It's to determine how many solutions. You use the quadratic formula to find the solution. You use the discriminant to tell you how many solutions. Okay. Yeah, tens, I love you too. Yeah, love you. Okay, partial fractions. So for the partial fractions topic, right, this is a very easy topic. So please don't gundu in this topic. And for those that are learning integration now, you should know that partial fractions will come back. Okay, so number one, whenever you're dealing with partial fraction questions, I always teach students to draw this diagram here. This diagram here, you will split them up into proper and improper. If it's a proper fraction, it means that you can just happily go down, okay, and just straight away use your factor. But if this is an improper fraction, you need to make sure, okay, that you do long division first. And how do you tell? Actually, I want to show. I see my different set of notes. So hang on. Where are you? Oh man. Oh, sorry. This? Okay, this one is better. Okay, so this one is better. So for partial fractions, right, remember that your partial fractions are written always a function over a function. So px over qx. So if it's a proper fraction, we need to remember that the px, the degree of px is less than the degree of qx. For improper fraction, the px is greater than equals to qx. So this one must remember. If the top is x squared, the bottom is x squared, this is a improper fraction, not proper. So be careful. When you are writing long division, right? Okay, from the long division format, you must be able to write it down into the partial fraction format, and then you solve for this. Okay. Now, the three for partial fractions are here. So linear factor, repeated linear factor, and non-factorizable factor. Okay. Now, in exams, you will never see repeated and non-factorizable together because that's too difficult. Most of the time, we will see linear and something else, or just maybe non-factorizable on its own. So please be careful. Definition of non-factorizable, it means those in the denominator that you cannot factorize. Example, x squared plus 4. Those cannot. But if you see x squared minus 9, those can. X squared minus 9 is the same thing as x plus 3, x minus 3. So be careful. Okay, a lot of people like to test trick questions like this. So just be very careful. You don't make careless mistakes like this in exams. Okay. And we're done. It's the same thing. Binomial theorem. Let's see the chat. No, Carl also love AMF contingent. What's the word for the maximum power degree? Highest degree. Okay. Binomial theorem. So binomial theorem is a topic that a lot of students hate. But why? It's so fun and it's so easy. So the difficult thing about binomial theorem is only those kind of questions with the value of n in the power. Then those are difficult, I agree. But for those questions where like, okay, I give you a few different types of exam questions. First type, number one. For those kind of questions where they ask you, find for me what is the x power 6 in this binomial. What's the method to use? TR plus 1 law. Okay, that is the method to use. Because whenever we are isolating just one term, right, we use the general R plus 1 term. Please don't be stupid. Go and expand all the way until power 11 or what. Can you imagine if the question asks you for power 25? Then you start from 1 all the way to 25 law, go ahead. You finish 2 hours also have not finished it. So be careful. Second type of question. For those that they ask you to multiply two things together, rainbow. Let's talk about it at the bottom here. So when we are dealing with the rainbows, right, we always ask ourselves, what multiply by what give you what you want? So give you an example. The question wants you to find what is the x cubed term. So you ask yourself, I have an x squared term. I need to multiply by what to give me x cubed? X law. Just like that. If I'm given an x term, I want to multiply by what to give me x cubed? X squared law. It's just as simple as that. When you draw these kind of pairings, right, it makes it very obvious as to what you need to do for binomials. Of course, there are many other tricks. Like for example, knowing like which term to stop at. That's a trick on its own. You must know how to do. Okay, that one I don't share. Go and figure out yourself. For independent term of x, remember that the power is 0. Okay, so for example, if the question is asking you, find me my constant term, find me my independent term of x, means that you are looking for x power 0. Last one, we talk about the most deadly type of questions, which is this kind. Okay, n choose r. So whenever your binomials are a power of an unknown, those must be a little bit more careful. Because for those kind of questions, you need to memorize the formula, which is here. Okay, so n choose 1 is just n choose 2 is n minus 1 over 2, n choose 3 is n minus 1, n minus 2 over 6. You can carry on the process. There is actually a proof as to how to work this out. Okay, but if you do not know how to use it, then just memorize. Okay, if you know, then maybe you can compute out yourself. But if you don't know how, you can read out online, you can look for the solution. But my suggestion is just to remember this, because most of the time they will go until n power 2. Unless your school is those that are more crazy one, then be a bit more careful for such questions. Okay. So curated notes for those that have on this page here, there's a scary question there. And also in my monthly practice questions, I always put power n questions. So please go and refer to them so that you can have some practice on these kind of questions. Binomial and exponential. Let's read the chat. If I'm doing any math, I don't learn. Yeah, if you have never learned any, if you are learning any math, or sorry, if you took A math, right, previously, right, there will be 6 chapters that you haven't learned yet. So you will need to learn first, before you learn the full syllabus, or else you will struggle a lot. Okay, integration. Carl, why your integration very bad? No leh, integration easy leh. Practice. Okay. Okay. So how do we find independent term of x? Okay, so for example, right, we always use the general r plus 1 term, and then we group all the x's together, then you force the power to be 0. Yeah, that's how you do it. Okay, so general r plus 1 term, group all the x's together, force for the x. Okay, I'll show you, maybe can show an example, because I actually have quite a bit of time. So, binomials, independent term of x. Okay. I don't have a question here. Oh dear. Okay. I don't have a question here, but okay, sorry, I don't have a question at the moment. Let me find, if you guys don't mind. So, not this. Practice question. Oh, I have much. Oh, no answers. Okay, funnily, I didn't set the question on independent term of x. Interesting. Okay, but if you're looking for the independent term of x, right? Yeah, you just need to go and basically group every single term together. Okay, group all the x's together, and then you force the power of x to be 0, and you solve. Yeah, that's usually the way that we do it. Okay, apologies for not being able to find the question. Okay, exponential. So this chapter, this one is the first quote unquote deadly chapter for everyone. I don't understand why, but sure. Okay, so exponential functions are always e to the power of something. Logarithms is log a or log base something, or log index something base something. Okay, remember that logarithms, right? There are two very special ones, lnx and lgx. For ln, this is base e, lg is base 10. In your calculator, you need to be very careful how. The LG button there is for base 10, not base anyhow. Okay, if you want to use the calculator, you need to change base. So be careful. Next one. This is very important. Okay, how do you change between exponential form to logarithm form? Now, most students will actually get stuck at this step. A lot of students, right, you see the logarithm form, like for example, log 3 equals to 5, or log 2x equals to 5, and then you get stuck because you cannot solve. Okay, you must remember that we always change from the logarithm form into the exponential form. And the way to do it is to use these arrows here. So I'll show you. So these arrows here is a way that I use to memorize my conversions. So just remember that the y stays in the exact same location. The a goes to the new base and the x goes into the power. Okay. Next, for sketching of graphs. So remember that for logarithm graphs and exponential graphs, when we are sketching the graphs, right? Now, for logarithm curves, you cannot cross the y-axis. For exponential curves, you cannot cross the x-axis. There are exceptions though. So for example, if let's say my exponential curve now has a -3, then you can shift down because the asymptote of the x-axis will actually shift down together with the exponential function. So it is possible for the curve to actually cross the x-axis in this case. But in the general case of e power x, it is not possible. So please remember that. Same thing for the logarithm curve. It is not possible for your logarithm curves to shift past to the y, but shifting towards left and right is not in the O-level syllabus, so you don't need to worry about that. Most of the time, just worry about e power x for this. Okay, if you're wondering the reason why logarithms cannot cross the x-axis and the y-axis, go and try to solve the equation. If let's say your graph crosses, you will realize that you're going to log a negative number, which is not possible. The laws of logarithms. So number one, remember that whenever you're adding two logarithms together, it's the same thing as u plus v. Okay, not this. Okay, sorry, what am I saying? Log au plus log av is the same thing as log uv. It's a multiplication, not an addition. This is wrong. Okay, many people, right, desperate in exams, then you will start writing log au plus v is the same thing as log au plus log av. No, that is wrong. So just be careful. Okay. A curve of negative x will flip. Like that. Yeah, I only draw the generic ones here. Let me show the remaining ones. Here. Okay, these are the 4 sample curves. Okay, I'll move on back. Okay, v is just an unknown. Yeah, it's just a random value. Doesn't matter what is it. Okay, so when we are dealing with the minus sign, that is a fraction. Okay, so just remember that is u over v, not u minus v. So be very careful. Now for the change of base, this is a very common formula that we always use. Remember that we change base when we look at the whole equation and we realize like, okay, I have base 2, base 8, base 16. Okay. So then we change everything down to base 2. Okay. Last one, which is the question variant here. Remember that whenever we see powers, right, there is like one is 2x, one is a single x. This is a quadratic equation. And we change this into a quadratic equation using substitution. Okay. That's all for logarithms actually. So that's basically it. Just remember that for this type as well, just when you want to put a little extra note here. So if you see questions like 2 power 2x, okay, maybe not 2, e to the power of 3x minus 1 plus, okay, maybe not 3 very scary. Yeah, e to the power of 2x plus 1 minus e to the power of x plus 3 equals to 2. Okay, and then you are supposed to solve for e. So this one, a lot of people will get stuck. Okay, so how to do is to use logarithm, use indices law to break this up first. So you get e to the power of 2x minus e power 3 e to the power of x equals to 2, and then you do your substitution. So this is eu squared minus e cubed u equals to 2. Yeah, then this is a quadratic equation. For that question, how do you change log 3 base 8? So for example, log 3 8, right? Same thing, just follow the formula. So if you notice, log, maybe my base is 10, so 10 8 over log 10 3. This is how we change base. So you just follow the formula. The v goes to the numerator, the u goes into the denominator, and the value of a will be my new base. Okay, I'm going to erase this. I'll leave that there. U is just an unknown. Yeah, it's just a random unknown. Yeah, just letters that I'm just using for fun. Yeah, you can use A, you can use B, you can use C. It doesn't matter. What is it? Okay. And then now, I don't think this one, the sec 3's, can you make it such that the base is 1? No. Why would you want base 1? Log base 1 is 0. Yeah. So be careful. It depends on your question, but most people won't make it base 1. I don't think your log, as in log 1 something, like that. This is not possible. It is undefined. As in the denominator is 1. Oh, yeah, of course. Of course. So for example, if this is log 2, 3, then just do log 2, change denominator to 1. Oh, log 2, I mean, it's the same thing, one. Log 2, 2. I mean, you still get back the same thing. Okay, because this is log 2, log 2, 3 over 1. Okay. Yeah. Okay, get done. Trigo. Okay, this one got a lot. So I will zoom in. So there's a lot of content here. So I'm left with trigo, coordinate jump, further coordinate jump, linear log, and the beginning of differentiation. Okay, until about 8:10. Okay. Oh, let's go into trigo. So this chapter is very big. Okay, so let's go slow. This one, I think my sec 3s are not very applicable anymore, but it's going to be coming, and this is a monster that is growing in the closet, haven't come out yet until you hit this topic. Okay, so let's start. Now for trigo, okay, there are 4 things that you need to remember. We split this chapter into 4. Ratio, the graphs, equations, trigo proving. There are 4. So number 1, when we are dealing with the ratios, this Tokaso part is in EMAF, so I'm not going to go through. This one, the cotangent, cosecant, and secant. These are your compound trigo ratios. So just remember that we look at the third letter of all of these trigo ratios to actually work out what are they and the inverses, or sorry, the reciprocals and what they are respectively. So cotangent is 1 over tangent, cosecant is 1 over sine, and secant is 1 over cosine. Take note that your calculators do not have cotangent, cosecant, and secant. If you want to type calculator, you need to change and make sure that it is correct. Okay. Special angles. So when we are dealing with the special angles, please remember that this is a list to memorize for 0, 35, 0, 30, 45, 60, 90. So some people actually don't want to memorize. It's actually fine. You can actually just use the calculator to actually tabulate out what are the answers. So in case, right, if let's say your brain not enough space to memorize, right, type calculator, you can get the answer one. Then for all those with the square roots, right? Let's say, for example, you type calculator, you do sine 45, assuming that you're in degrees. Okay, then you should get an answer of 0.788 something, if I remember correctly. Okay, then how do you make this into a fraction? Just go and square the value. And then you will see that the answer will be, I think, 2, something like that. Or 1 over root 2, so it'll be half. Okay, then after that, you just solve it just by square rooting the calculator answer. Okay, this is for special angles. Now, this is important. So for special angle questions, right, sometimes they will ask you to leave certain trigo numbers into exact form. And the way to do it, or the way that we do it, is to use addition formula and to always use out these numbers, 0, 30, 45, 60, 90. So example, a question will ask you what is sine 105 in exact form. So how to find? Who's there? Sine 105 in exact form. Just remember that 105 is just a linear combination of 60 and 45. And then we can just work it out using addition formula. Sine 60 cosine 45. Sine 60 cosine 60 plus sine 45 cosine 45. Then all of these have exact form. You can write in square root form. Okay. ASTC. Okay, so this is the next chunk. So for this section here, you need to remember your ASTC rules. So A means that all is positive, S means that sine is positive, T means that tangent is positive, and C means that cosine is positive. Okay, so just look at this chart here. It will help you to remember which of the following is positive. Now, whenever your angle lies within a certain quadrant, like let's say for example, if the value is sine theta is equals to half, and we're in degrees, so we can see that the value at the right is a positive number. So we know that we are in quadrant 1 and quadrant 2. So therefore, there are two answers. Answer will be 30 degrees or 150. Okay, and the way that we tabulate is to use these formulas here at the basic angle itself. So you must remember that when you are solving trigo ratios or trigo equations, we solve for the basic angle first. And then we will work out the 180 minus alpha for second quadrant, 180 plus alpha for the third quadrant, and 360 degrees minus alpha for the fourth quadrant. Okay. So like this. So this is just an example. Okay, I have cosine 30 is equals to root 3 over 2. So if you know your ratios, this is 30 degrees. So basically, how do we tell which quadrant they are? We look at the right. We see that root 3 over 2, this is a positive number. So since this is positive, we are in the A quadrant and the C quadrant. If we are less than 0, then we are in the S quadrant or the T quadrant. Okay. Now take note that whenever we are doing these kind of quadrant questions, it is possible to go for an extra rotation. So an additional rotation. Just look at your range of your question. They will usually tell you how far to actually go. Okay, so this is important as well. Now there are questions out there, and this is a very popular question now these days, is this kind here. So for example, the question states that tangent A is equals to 5 over 12, cosine B is equals to negative 3 over 5. They tell you that A and B are in the same quadrant. Identify which quadrant or solve for something. How do you do that? You need to identify which quadrants they are in first. So for example, for this case here, 5 over 12, okay, this is Pythagoras triplet lah. Okay, so we will know that A here, this is in the A quadrant and the T quadrant, which is quadrant 1 and quadrant 3. Cosine B is negative, so this means you're in the second quadrant and the third quadrant, therefore we are in the third quadrant. Sometimes they will actually give you hints on what your ratios are going to be. So remember that acute is in the first quadrant, obtuse is in the second quadrant, and reflex is either in the third or fourth. Okay, usually we cannot tell. Usually we'll tell using this, like what the size of the angles are going to be. Okay. If you're going for the negative cycles, then we go in reverse. So the fourth will be the first quadrant, then the T quadrant will be the second quadrant, and whatsoever. Okay. I'll go into graphs first because this is easier. So the graphs here, number one, your sine curve, cosine curve, and your tangent curve. So, excuse me. So there are three things that we always look out for in a graph question. So amplitude, period, and the vertical translation. So for the amplitude, right, is basically how high your curve is going to go. Your period is how long does it take to complete one cycle. It's the same thing like if you study physics, you should know. And then for your C, this is called the vertical translation. Now, this name may not be in the O-level syllabus, but I teach it to students because it's very easy to understand. Vertical translation basically means how much of a graph you move up or you move down. O-levels don't have left or right. It's always up or down. Okay, and then the y equals to a something bx plus c. This is actually how we tell. The graph will always move up if it's positive, and the graph will move down if it's negative. Look at the blue lines down there in all of the ratios will actually tell you what are the respective periods they are going to be. And how do we compute the periods? Okay, so something like this. If let's say you have a question like this, how do you actually work out what are the values of A, B, and C? You must be able to tell. Number one, first thing I will always teach students to do is to find where is the equilibrium position. So the equilibrium position is basically this middle line that will cut the graph exactly in half. This middle line, from the middle line, we can actually tell the value of A and the value of C straight away. From the equilibrium position to the maximum point, that is the A. From the equilibrium position to the 0, that is the C value. Okay, the equilibrium position represents the blue line down there. And then how do we tell the period? We just see one cycle, how long it takes, use the formula 360 over period to actually work out the value of B. Last one here, okay, positive curves and negative curves. Sorry, I missed a line here. So if the graphs are positive, they are the ones in white. The graphs in red are the negative curves. So last year, 2021 N-level math, AMath, the negative tangent came out. Okay, so just be very careful. It can appear one day. So please go and study your negative curves as well. Know how to draw them. Or else when it comes out, everyone will say SCAB very bad. Okay, so please be careful. Next, we go into equations. So whenever we are solving for trigo equations, A-level trigo graphs will move left and right. A-levels, you will learn how to graph left and right direction. Any graph will move left and right. But O-levels don't have up, left and right. Okay. Equations of a curve. So just remember, right, that your equations are always based on your range. So the questions will always provide to you the range, and they will tell you what I lost my train of process. Whether you're in degrees or radians. Okay, that's what I was trying to say. So what's the step-by-step process? First thing to do is to identify your ratio, whether is it positive or negative. If it's positive, then we identify the quadrant. Please remember that we cannot solve for the ratio straight away. We cannot solve for theta. You will get it wrong. Okay, we are solving for the basic angle first. That's the first thing to do. Okay. If the value on the right is actually a negative value, we need to take the positive. Okay, so if let's say the question there is cosine theta is equals to negative root 3 over 2, then it needs to be when you take your inverse, it must be the positive value. So be careful. When we are solving for the basic angle, we identify which quadrants we are in. So usually I ask students to draw the diagram, circle it, and then solve. And make sure that the answers that you get are within your range. Okay, if the range is given in the question, follow the range. If the range is not given, then don't need to follow. Okay, most of the time they'll give. Okay. Last one, my favorite section, trigo identities. So a lot of people will ask how to study for trigo identities. Fun fact, it is impossible. Okay, you can just practice as many as possible. Okay, so that you can get a feel of how to actually do trigo proving. But there are tricks that I can share with you. So I'll share with you some. Now, the list of all the trigo proofs, they are given to you in exams. So the list of all the identities, right, they are given. So you don't need to memorize. But some tricks that I usually teach students to remember, okay, there are two in general. Number one, whenever you get stuck with a trigo proving question, okay, for example, you go in the right, you go from left to right, and you get stuck in the middle. What I will do is to ask students to go from the right and then go down. You get what I mean? So for example, if one here, then you start, you go this way, and then you get stuck. Okay, so for example, you hit a wall. So what I will do, go from the right and go and try to meet in the middle. Once you meet in the middle, then you can go one more already. Okay, trust me, this works all the time. Okay, so sometimes, right, working from the right going into the middle will actually be very easy. From the left go to the middle also very easy. But then want to make one full loop, then because you got two sides, it becomes very easy to understand. And that's how you do it. Okay. That is trick number one. And trick number two, okay, is for this particular one. So it's stressing on these three. Okay, so common question that I always get is how to tell whether what cosine 2a value to use. Actually, very easy to tell. You just look at what is on the right. If you see on the right, there is no one value, or there's something missing from your original question, then you use all of these ones to wipe out the whatever is in the original question. That's one of the tricks also. But all this really comes from experience. It's very difficult for me to tell you like all the possible ways of solving. Very difficult. Okay, practice. This one really must practice and do non-stop. Then it will become very easy. Okay. And also take note that trigo proving comes back in integration for my side first. Our formula. So this one is another one, very classic, always comes out every year. Go and study how to calculate the R value and the alpha value. Okay, this one shouldn't be too difficult. The proof is at the bottom here. So if let's say you forget in exams, you can just brute force it out using the addition formula. Okay. And we're done. This is trigo. How do you do proving of trigo? Yeah, like I see already, okay. So asking me how to do trigo proving questions is very difficult because I don't have a question. The way to study trigo proving questions, or the way to do trigo proving, is to really practice. A-math must practice one, or else 真的不会晒. Okay, yeah, I need to move on because I'm running out of time. Okay, very good. So common questions that come out. How to find min-max value? So same thing, you sketch the graph. So in your head, right, for your min-max value for this kind, right, you just draw what is the cosine curve will look like. Go and find what's the maximum point, what's the minimum point. Okay, this for min-max. And then for principal range, go and study the list. Okay, so for sine and cos, for sine is between negative 90 to 90. No, yeah, wait, principal range is negative 90 to 90. Yeah, negative 90 to 90. For cosine is between 0 to 90. And then for tangent is negative 90 to 90 as well. Yeah. Okay, so this one I didn't put it in because it wasn't very important. So I left it out. Okay. Cycles. What cycles? What do you mean by cycle for trigo? So I don't understand what's that. Okay, I'll move on first because I'm running out of time. Sorry. So coordinate geom. Okay. So the A-math coordinate geom, right, is entirely from your E-math coordinate geom, just adding on two formulas. Number one, midpoint. So just remember that midpoint is just the average of your two coordinates in the question. So for example, if the question gives you here maybe 2, 1, and this here is 3, 4, okay, you just find the midpoint. So this is 2.5 and 2.5 as well. And this is just the average of your x coordinates and the average of your y coordinates, and this will give you your midpoint. Next one that is very common, this is the next concept that is different from your E-math, will be this, which is your shoelace. So remember, number one, your shoelace actually comes from the modulus bars. So this modulus bars here will force whatever value that is within these bars to be positive. Okay, so in schools, right, they always teach you to, must go in clockwise or go in anti-clock. Okay, to be very honest, whatever direction works, you will still get the correct answer. There's some limitations though. You need to make sure that when you're going in the shoelace method, you go in the same direction all the way. So if you're going clockwise, you go clockwise all the way. If you're going anti-clock, you go anti-clock all the way. Okay, do not jump around. So let's say if the figure is like that, don't do like that, like that, like that, like that. You'll get it wrong. Okay, if you want to do, you do like that, or you do like that. Okay. And you must remember also for shoelace, you must repeat the very last point. Okay, repeat the same point. Okay, repeat the first point that you choose, or else you will lose a particular value there. For perpendicular lines, remember that the product of the gradient of perpendicular lines is -1. That's important. And the last one is for perpendicular bisectors. For perpendicular bisectors, okay, remember that we are always dealing with the gradient of the line, which is perpendicular to the one that you're interested in. So just calculate using the property above, and we always look for the midpoint. Why? Because perpendicular bisectors, they cut the line exactly in half. And that's the reason why. Further coordinate jump. So this chapter, a lot of students struggle very heavily with. Okay, I also don't know why. There are some questions, yes, I agree they are difficult, but just be careful okay, of the way that you do it. So standard form is the x minus a squared plus y minus b squared equals to r squared format. Remember that the center is AB and the radius is r. For the general form, x squared plus y squared plus 2gx plus 2fy plus c equals to 0. You must be very careful that the center is negative g negative f, and the radius is calculated using g squared plus f squared minus c. Remember how this formula here is a plus c. The radius formula is minus c. So be very careful. Reflection. Okay, this is a very common exam question that always comes out, and they will always ask you how to work out so the questions will always ask you what is the equation of a circle when it's reflected about a certain line. So I'm going to teach you something to remember, and you'll remember this for life because it's a stupid example, trust me. Okay, so first thing, whenever we are dealing with a reflection, okay, number one, when you look into a mirror, okay, imagine you look into a mirror right now. Okay, I look into the mirror, my face, look into the mirror, and I look at my image. Will my face get fatter or will my face get skinnier? No, it should be remaining the same. Okay, I wish my face can get skinnier because I'm very fat. Okay, but cannot. Okay, this is a normal mirror. Okay, so your radius will never change. Your circle of whatever size will remain the same size when you're looking at the image. Now, of course, if you look at an ordinary mirror and you see that your face suddenly very skinny, something wrong with your mirror very scary. Okay, so please be careful. Now, how do you remember x-axis and y-axis? For example, if you're reflecting about the x-axis or reflecting about the y-axis, very easy to remember. If let's say you're reflecting about the y-axis, which is a vertical line, okay, this is just like an ordinary mirror. Now, when you look at the mirror, okay, let's say, for example, you're standing 2 meters from the mirror. When you look at your image, okay, will your image be very, very far away or will your image be very, very close to you? No. Okay, it should also be 2 meters away from you. If the image suddenly go very close to you, your mirror haunted, very scary. Okay, so be very careful. Okay, so this means what? Your x coordinate remains the same and your y coordinates always you just flip the minus sign because the length between you to the mirror and the mirror to your image will always remain the same. X coordinates will always remain the same. The reason why, very simple. You look into the mirror, will you be floating above the air or will your legs be chopped off and you only see half of your body? No, same problem. If you see that in your mirror, you throw. Okay, very scary. Just remember that your x coordinates will never change. Your y coordinates will always just flip. Okay, it's the same thing for the y-axis. Now just imagine that you're looking at the mirror on the floor. It's the same logic. Okay, so if you're very far away in the floor compared to where you are standing, same thing, your mirror is scary. Okay, or if let's say you're standing at a certain point and you're suddenly standing very far away inside the mirror, also very, very sus. Okay, so be very careful. This is how we remember reflections. Okay, so remember this haunted mirror example, trust me, it helps. Okay, so yeah. So now, the normal part, I'll just leave it out first, but just know that normals comes from differentiation, so I'll just leave it out. Linear law. I know my linear law notes are just like that, but linear law just need to remember it deals with logarithms. Okay, so for example, if you are always looking for the form capital Y equals to M capital X plus C, okay, we are always looking for capital Y's and capital X. Remember that your capital X and capital Y's cannot contain any unknown. It must just contain the pure X's, the baby X, and the pure baby Y's. Okay, it cannot contain any unknown, or else you cannot sketch your graph. Okay, remember that when you're sketching for linear law curves as well, you need to remember to convert your table of values into the new X and Y axis, or else same thing, you will get it wrong. Last one, just a special tip for those drawing graph questions for linear law. Most of the time, the questions will ask you to draw between like a certain range. But remember, for AMF, you're actually allowed to extend the line all the way to the x-axis or y-axis because you're going to find the y-intercept anyways. For EMF, you cannot do that. The reason is because the questions will limit your range. Be careful. Okay. This chapter is a chicken feed chapter. So if you need And there's a graph question, most of the time I advise students to draw first and then do the rest of the paper. But of course, up to you. Okay. Differentiation. So I'm going to go through differentiation only. I'll not do integration and I'll not do kinematics. For those that need help with those two topics, then you look for me. Okay. Let's see if I got any questions. Is modulus part of syllabus? No, it has been taken out. So, equation or circle, just know both. You need to know both. Any tips for doing circle questions? I struggle with circle questions a lot. Same thing. If you are struggling with any topic in the syllabus, right, go and practice the topic. Okay. Yeah. I saw your PM already to whoever just messaged me. Okay. So if you are struggling with a certain topic, go and practice that topic. Okay, it will help you. Okay. Trigo, when do we divide by cosine x? That's a very strange question. Very random question. So I need a context because just saying that I cannot answer. Yeah. Sorry, I need to go into differentiation first, then we can end. So for differentiation, right, please remember how, for my sec force, power minus 1, power bring down, power minus 1. Okay. So remember this for life, power bring down, power minus 1. When we are dealing with products of two terms, then it's product rule, division, quotient rule. Must remember that both u and v must contain an x term. Okay. Now, for trigo identities, the exponential ones and the logarithm ones, remember that for trigo and exponential especially, you need to differentiate your power and your angle respectively. So for sine ax plus b, there must be the a in front because you're differentiating your angle. This is very important. For increasing and decreasing functions, so these are all the applications already. So increasing functions, you just remember that your dy dx is greater than 0, dy dx is lesser than 0 for a decreasing function. Any questions that deal with stationary points, okay, it means that the dy dx is equal to 0. Now there are other examples of the word stationary points, like for example, turning point. There's another one. When you see turning point in the exams, it also means dy dx equals to 0. Two more that is very common that I've seen before. Number one, for example, they say there is a certain point on the graph where the tangent to that point is parallel to the x-axis. This should also tell you that dy dx is equals to 0. Because parallel to the x-axis means that your gradient is 0, dy dx is 0. Okay. And number four, the next one also is pretty close. It's just saying that the tangent at a certain point is equal to 0. This means that there is a stationary point at that point. Okay. Whenever we are dealing with the nature of anything, okay, we are dealing with the first derivative test or the second derivative test. Please remember that the first derivative test is foolproof. You will never go wrong. For the second derivative test, that is slightly different. We'll go through that in a bit. Now, for the first derivative test, remember to draw this table, x values, dy dx, and the shape of the curve. For the first column, okay, is always x minus 0.01 values, and the last row is always x plus 0.01. Why 0.01? We want to go as close to the value as possible. We don't want so far because or else the answer will be very, it is possible for the turning points to be very close to each other. So we want the values that we choose to be as close as possible so that we don't make any errors there. Okay, the respective images are there. So maximum is always up, straight, then down. Minimum is the reverse. And then inflection is when there is both ups on both sides or both downs on the other side. For the second derivative test, like I mentioned just now, there is a situation where you can fail, which is when your d2y dx squared is equals to 0. When the d2y dx squared is equals to 0, your second derivative test has failed. You need to use the first derivative test. This is very important. Okay. And also must remember how d2y dx squared greater than 0 means it's minimum. d2y dx squared less than 0 is maximum. So be careful. Next concept is gradient tangent normals. Remember that your normal is always perpendicular to your tangent. Okay, and the gradients, the product is -1. So an example of a graph, it looks like this. Usually these kind of questions I'll give away, so please must be able to do. For maxima minima questions, okay, dy dx is always equals to 0 because we are dealing with the maximum point or the minimum point. Now, for this kind of questions, most of the time, the part A will be a show question, and a lot of students will struggle with the show question. So please do not give up on the show question. Okay, if let's say your show question you cannot do, you still can do the rest. Because most of the time, they will just ask you, for example, part A is ask you to show this volume, V equals to something. Part B, find dV dt, for example. You still can do because the question will give you the show. Okay. Last thing, whenever the question asks you to compute what is the maximum value, you must prove why that value is minimum or maximum in order to get the full marks of the question. Unless the question says don't need, then you need to be, then don't need lah. Last one is rate of change, then we end for today. So for rate of change questions, it's always written in this form. dy dx is equals to dy dt multiplied by dt dx. Now look at this way that I've written it here. Notice the two boxes there, they are actually the same thing. Okay, as long as whatever is within those two boxes are the same, you can get out to dy dx. Now, of course, it depends on your question as well. If your question is like dy dt, then you do dy over something is equals to something over dt. That's how you compute out. Okay. So for example, if the question is asking you to identify what is the rate of change of x, we find dx dt. dt will represent the rate of change. Last one, for decreasing values, you need to remember, if let's say water is leaking out of a container, or they tell you that the rate is decreasing, it's a negative value. Okay, and we're done. This is the whole of differentiation. With 2 minutes to spare. Outstanding. Okay, why the chat so noisy? Let's check some question. Okay, someone is asking me when to use second derivative test, when to do first derivative test. Actually, it's not true that it's a gamble. There are ways to tell. Basically, the way to tell is you, okay, this is a very crude way of saying it, but you look at your function, okay, and then you go and check. If let's say every single term in this function contains an unknown or a variable, you know definitely when you substitute 0 is confirmed 0. That's one trick. The second trick, if your differentiation is very strong and you can differentiate in your head, then you differentiate in your head first. Then if you know that it is wrong, then you don't even do the test. Just straight away do first test. Okay, that is the trick. How easy is any AMF? It's even easier than AMF. AMF in AMF. It's chicken feed. Will you still give notes for the? Yeah, I will. What do you find sine 4x using triple identities? Sine 4x. Sine 4x is sine 2x plus sine 2x. Sine 2x plus 2x. Then you use the addition formula. Integration easier than differentiation. That's not true. Can you go through how to explain approaching zero questions for exponential? Oh, okay. For that, whenever your exponential functions is approaching zero, it means that it's going very, 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 very close to the axis like this. Yeah. So it's either this or is, for example, approaching infinity. Like those kind of questions where they ask you like, what happens when the value becomes very big? You just need to remember that your exponential functions will always be equals to 0 when it goes like very, very big. Yeah, just remember that. Okay. The concept as to why that one is out of the syllabus is very far away, so you don't need to know. Teacher, how come second derivative test less than 0 is max and vice versa? Explanation, if you want the full explanation as to why is the case, A levels will explain, O levels never will explain. Yeah, it's because of concavity. Never learn. So forget it. But if you're interested, please go and Google. Sketch y equals to ln 2x plus 1. Yes, I got see before. But those kind is difficult. Yeah. Okay, so what I'm going to do now is I'm going to do the Kahoot session. Okay, so give me a sec while I share the screen. Wait. Okay, for those that participated in the eMath one, don't talk so much. Okay, just keep the whatever secret that you have alone. No, I never share anything, but just yeah, keep it to yourself. Don't need to tell the whole world. No, it's a different quiz. Okay, so don't need to worry. Okay, so I've joined it. Wait. Okay, I'm going to share my screen. Okay, so the reward for this Kahoot, same thing, you'll get a set of the curated notes, okay, for free. So please go and join the Kahoot session. Okay, then for the winner, okay, what you do very simple, you just screenshot, you just show me that you, I'll remember anyways. Then after that, you just text me on Telegram. Then I'll send you a copy of the notes for free. Okay, join. Hi, for Trigo, if they ask for longest distance, yeah, your maximum value, correct. Okay, I should have 95 people here, excluding me, so 94. Okay, I'll make this quick because I do need to rush off. Okay, so for those that are doing this for the first time, let me share with you first. Okay, this is a true-false quiz. Okay, so everything is true-false questions. So it's either or lah. Okay, of course the answers, whether is it true or false is not important. You should know why is it true or false. Okay, I'm going to start soon because I need to rush off. Okay. 80 people, there are 94 people here. Okay, the questions are all Sec 3s can do and all Sec 4s also can do. Yeah, because the topics I stopped at is logarithms. Yeah, I never go anything further than that. Okay, I'm going to start. So for those that haven't joined, please faster. Is the tens there? Can you get out? Joking. Okay. For those in the chat, please be more sensitive with what you say. Okay, I'm going to start. Ready? Okay, I'm going to start in 3, 2, faster. I'm going to start in 3, 2, 1. Okay, I read the question now. So the question is, given a curve that is strictly positive and above the x-axis, then b squared minus 4ac is greater than 0. Is that true? How many people are there? 86. Okay, I think I mentioned just now, remember that strictly positive means that the graph is floating above the curve, therefore it's false. Very good. Good job. All this very fast, huh? Okay, next. True, false. Okay, has everyone answered? Okay, so the question is the following computation correct? Okay, yeah, answer is false. Okay, so just be careful. Okay, because this is greater than 0, so the range actually should be less than -6 and greater than -2. Okay. Very good. See the lokesh, I think I don't know. Okay, very good. Okay, is the following computation correct? Hey, try. Okay, answer is false. The reason is because a squared minus b squared is not the same thing as a minus b squared. So be careful. Okay. Next. Very good. Next. Wait, where's the next button? Okay. Sorry. Okay, so given that x plus 1 is a factor of a polynomial fx, then by the factor theorem, x1 is equal to 0. F of 1 is equal to 0. Okay, answer is false. The reason is because x plus 1. So the value should be -1, then it should be equal to 0. Okay. Very good, very good. Wow, all the 4,000 points. Wow, not bad. Okay, very good, very good. The tens never play me? Oh, I never see his name. Okay, stop with the cow, please. Thank you. Okay, try. X squared plus 4x plus 9 over x squared minus 196 x plus 1 is equal to that. Is that true? No, that's not true. Okay, the reason is because x squared minus 196 is x minus 14, x plus 14. Okay. Next. Wow, another 5,000 points. Very good. Okay, so this one is x squared plus 4x plus 16. Okay, this is false. That's the denominator. So be careful. Very good, very good, very good. Next one, true or false? Yeah, this is the 7th question. Very good. Okay, this is false. The reason is because this 9 here never multiply to this 3y. Okay. Very good. Okay, I think there's only like 76 people here. So congratulations to those people that said that this is false. Because this is true. Okay. Exponential curve and logarithm curves are, they are reflections about the line y equals to x. Okay, so it's not everything true. Not everything false. Very good. Okay, next one. Okay. Okay, so for this one, be careful. Okay, so the reason is here. Okay, so it's wrong to actually split up the logarithms like this. So its answer is false. See, all my
on the leaderboard.
On the 9,000 people. Okay. Still noob. Why never talk? Lousy. Okay, this one must be careful for. Okay, this one is false. So this one must be careful. Okay, this one actually has a solution. So for this one, this is a slightly more difficult question. So I won't review how to do this, but if you're interested, you can go and try. How do you actually find the values of x for this? Okay, let's see. 9 out of 10. No. Very good, very good, very good. 9 out of 10. See, all thing, all false. Then 9 out of 10. Wow, very good. Who's this? Very good, very good, very good. Okay, can you PM me? PM me, then I send you a copy of the curator. Okay. Okay, very good. Thank you. So be very careful. This one, 12% of the people got it correct. So be careful. Okay. Okay, so let me wrap up today and then we will call it a day. Okay. Okay, so last things. Okay, so a few things that number one, all the notes that you have been seeing so far, right? The white notes are actually all from the curated notes. So later after this, I will actually no, I will not upload, but you can buy a copy of the curated notes. Okay, you can use the link down there to actually purchase. Okay, it will come with two books, book A and book B. Book A is actually all the algebra chapters. Book B is all the geometry and calculus chapters. Okay, it's a package together. Next, so if you actually need more help and actually if you like the way that I teach, okay, so one thing is that I do group tuitions and I also do crash courses as well. So if you're interested, you can actually come for a trial lesson or you can come to attend the crash courses. So here are the sessions, okay, for the group tuition. So let me share first. It's 2 hours. So all the materials I'll give you. So you'll get homework, lecture notes and everything. So the AMAth sessions are here. The Monday 3 p.m. class, that one's a brand new class that just started. And then the Thursday is my running current class. Okay, the class has quite a lot of people there. So if you're interested, you can come and join. Okay, the physical lessons will be held at Toa Payoh and online lessons will be via Zoom. Also, one more thing. So if you notice, there's an EMAth and AMAth session. So if you're interested in both EMAth and AMAth, right, there's actually a 10% discount going on. So yeah, you'll be given so if you have if you sign up for both subjects. So next one is the crash course. So the crash course, what I will be doing is that I will be going in detail all of the different chapters, and I'll also be giving you questions as to how to solve certain questions and some of the answers to questions. And I'll also be going through the syllabus in detail for the 3 hours. So the pricing is there, 180 per module. So there are a total of 3 modules. And if you go for all 3, it'll be 450. Okay, so the crash course will actually cover all the concepts, everything that you need for the O's, okay, exam strategies, how to answer the questions, and I'll also be giving you a set of curated questions so that we can go through them together in class, and I'll also give you the solutions. All the crash course sessions will also come with a free set of the notes, so yeah, just take note of that. Same thing for the group tuition, it will also come with a free set of notes. Location, you'll be at Yishun, so it's very close to Yishun MRT. It's a fully air-conditioned place. It's a very beautiful place. So if you're interested, do join us or do join me, and then I can help you with your AMAth. Okay, these are the topics that I will be covering it's AMAth crash course, sorry about that. So for the first module, okay, this will be a Wednesday. It will be all the algebra Sec 3 topics. Okay, Sec 4 also can join, of course. Then the second module will be Sec 3 geometry. So that is the trigo, coordinate geom, further coordinate geom, and plane geom. And then the last one will be the calculus topics for Sec 4s primarily. Okay, that will be on the 22nd of June. Okay, sign up is on the website. You can also go into the website to go and look for them. Last one. Okay, these are the resources that I provide for Overmark. So number one will be the free notes that I upload. Later, I will be uploading these black color notes into the Telegram channel. Take note that these are actually the old last year ones. I'll upload the new ones closer towards the O's. Okay. and also monthly practice questions. So every month I'll upload like a batch of questions, maybe 4 to 5 questions per topic. You can go and try. Answer key will also be provided. Last thing is consultation. So if let's say you need help in anything, you can always ask me for consultation. I can help you with the topic as well. Okay, of course, this is free. Okay, but of course, it's subjected to my availability, of course. Okay, last thing is the Kahoot. So I've already completed this. So congrats to whoever won it. Okay, and the last thing is that if you enjoyed this revision session, okay, leave us a review, and yeah, so if you enjoyed, let us know that you enjoyed it. Okay, if not, that's all for today. I hope everyone enjoyed yourself. You learned something from me. I'm going to upload the black color paper notes now. Okay, then if not, I do need to end now, so I'm sorry. If you have any questions for me, please look for me on Telegram. Okay, you can PM me. Okay, then I will help you with that. Okay, so let me just look at the questions first. If anyone has any questions. Okay. Okay. Yeah, so got nothing. Okay, great. So that's all. Thank you very much. Take care, everyone, and see you guys when I see you guys. Bye-bye.
Bye.
Bye-bye. Okay, so I'll end the call here. Okay, so if anyone can just PM me for any help or what. Okay, bye-bye. Take care.